All right, welcome to Unit 6, Day 4. This video is going to be talking about parallel line symmetry. So we're going to start off with some work with triangles and proportions still, but we're basing this on when we have two parallel lines in a given situation. So here's what we have to start with. We're going to start with the triangle proportionality theorem, which states this: if a line is parallel to one side of a triangle, and it intersects the other two sides, then it divides those sides proportionally. Okay, so these segments, AD, DB, and CE and EB are all proportional. And so I'll tell you what that means for this example. Okay, if DE is parallel to AC, then we could write a proportion of these lengths. BD over DA equals BE over EC. Okay? So now we don't have to use the similar triangles BDE and BAC to show that BD is proportional to BA. We can just use the individual segments here. All right? And this has a converse that also is true. If these are proportional segments, then we can conclude they are parallel lines also. All right, so let's try some examples. Okay, in example 1, we are given two parallel lines where one is parallel to the side of a triangle and it intersects these other two sides of the triangle, so these are proportional lengths. Okay, now what I want to show you is that really we can just transfer the way these are written a lot of the times into a proportion. 14 over x equals 12 over 15. There's a lot of correct ways you could write this. You could say 14 over 12 equals x over 15. Okay, but you don't need to think of all the different ways to write it. You just need to find one that is true. 14 over x equals 12 over 15. We could not say 14 over 15 is equal to 12 over x. That won't work. Okay, so make sure you're setting it up correctly then. And then we just cross multiply. X equals 210, and then divide by 12. We get that x in this case is 17.5. Okay. Let's try another example. Okay. And a reminder again, at any time if you need to pause the video to copy down the figures, you can. But in this example, we are given this is x, and this segment is 36. This segment is 45, and the entire length is 55, so be careful here. We're not going to say x over 36 equals 55 over 45 because I want to know that part. X over 36 would equal this part over 45. Well, it's easy to see that 55 minus 45 is 10. Okay, so we can write our proportion like this. X over 36 equals 10 over 45. Okay, or you could say x over 10 equals 36 over 45. Either way, you're going to end up multiplying 36 and 10 and x and 45. Times 10 is 360, and this is 45x. Divide both sides by 45, and x is 8. Okay? So that is all based on the triangle proportionality theorem. So for the next example, example 3, we're going to use the converse of that theorem, which stated this: if the two sides of the triangle are divided proportionally, so if there's a proportion that's true, then the segments have to be parallel. So we're going to use that in the next example. So here's our first part of example 3. We want to determine if MN is parallel to JL. So we're going to check that proportion and make sure it works. We're not just going to assume that it's true. We want to check out the numbers and make sure that it works. And I'm going to show you how to set this up the easiest way possible. We're just going to check 11 over 15.4 and see if that equals 10 over 14. We're going to write it this way. 11 over 15.4 question mark above that equal sign, and see if that does equal 10 over 14. Now we set it up correct in the correct order. The easiest way for me, when there's decimals like this, to check and see if it's true is to cross multiply. Remember, if a proportion is true, then the cross product should be equal. And so when we do 11 times 14, we get 154. And when we do 15.4 times 10, we also get 154. Since the cross products are equal, these ratios are equal also, meaning they are proportional or proportional. So since these segments are proportional, we can conclude that yes, Mn is parallel to Jl. Okay, so we're going to try that again on part B. We're going to check these segments to see if they are in fact proportional. So we're going to try this, you could write this a couple different ways. I'm going to do 15 over 18 equals 4 over 5. We're going to see if that's true. So I'm going to put a question mark above the equal sign. And then we'll cross multiply. Multiply 5 times 15 and 18 times 4. If we do 15 times 5, we get 75. And 18 times 4 is 72. Those do not equal each other. So these are not proportional. These ratios are not equal because their cross products are not equal. And since the ratios are not equal, that means these segments are not proportional, so these lines cannot be parallel. So our answer is no. Okay? All right, and that leads us to the second portion of our notes. Proportional parts and parallel lines. Okay? And so anytime we have two or more parallel lines cut by these two different transversals, it's kind of like we're looking at a part of a triangle. Okay, if I continued these, they would eventually meet up here, and then we'd make a triangle, and I get multiple parallel lines. We get proportional segments also. So here's what we have. If we know that AB is parallel to CD, which is also parallel to EF, so we have all of those lines parallel, then we know that these segments here, 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 and here are proportional. So we can write a proportion. We can say something like AC over CE has to equal BD over DF. Now, there's multiple correct proportions we could write. I could say AC over BD equals CE over DF. Okay? I could switch some of these around, but that's the same general idea. So let's try and do some examples using this principle. Okay? Got parallel lines here, here, and here. And these segments, 45, 18, 52, and x, we can use a proportion to find x because these are all proportional. So one thing we could do is 45 over 18 equals 52 over x. Or you could do the same proportion if you see it a little bit differently. You could do 45 over 52 equals 18 over x. In either way, we will multiply these and these. And these two. Okay, either way you're multiplying 18 and 52. So either way, we cross multiply, we get 45x equals 936, because 18 times 52 is 936. And then we can divide both sides by 45 and get that x is about 20.8. Okay? Let's do one more example. So here we've got another set of lines intersected by three parallel lines, and we're given the expressions using algebraic expressions. Instead of just an x, we're using other expressions, but we can still set up a proportion. In this case, I'm going to do 2x plus 2 over 21 equals x plus 3 over 12. And we should be pretty used to doing problems like this. When we multiply across multiplying this way, we have to distribute 12 to the 2x and the 2, and 21 to x and 3. So we get this, and we cross multiply. 24x plus 24 equals 21x plus 63. And we can subtract the 21x from both sides, and subtract 24 from both sides, and get the next line. The 3x equals 39, and then divide by 3 on both sides, and we get x has to equal 13. Okay, so that's kind of the main idea behind this lesson, just using proportions given parallel lines either in a triangle or outside of a triangle like this. You should be good to go. We will do some more examples in class, and you'll get the assignment in class.